Děkuji. Dobrý den, já jsem Jaroslav Tulach a přijel jsem z Prahy. Actually, I should probably switch to English. Okay, so I'm Jaroslav Tulach and I'm here to tell you about a project which I'm working on for last year, usually over the evenings and Sunday and Saturday days. The goal of this project is basically get Java to the browser, be able to code in Java and execute your program in any browser, even without the official Java plugin installed, actually without any plugin installed. So, what motivated me to start to work on this project? In 2008, I wrote a book about API design, this one, basically. And it contained knowledge that I gained after 13 years of designing and architecting NetBeans, which was what I did since I left high school, university. And actually, when I was writing the book, I wanted to somehow demonstrate that there is so huge need for programmers that even a guy like this, who apparently does not know how to program and well, wants to program HTML, can actually get a job and can be employed and can be probably also important and useful. But at the time, I also wanted to point out that, well, it's a strange sign because nobody can code HTML. HTML was a markup language. You write it, but you don't code it. There was no code. But since then, situation changed. These days, we are coding HTML because every HTML application now contains a lot of JavaScript. And JavaScript is programming language, and you can code it. So I actually like how HTML evolves and how HTML looks like these days. I just don't like JavaScript. What is your attitude to JavaScript? Who writes JavaScript code? 1/3, maybe more. Are you happy with that? No! That's the fantastic answer. Thank you. Thank you. So I will show you how you can, well, probably you write JavaScript for the browser, right? Not on server side. Anyone writes JavaScript on server side? Okay, I won't help you guys. But those of you that write JavaScript to be executed in browser will, after today, have another option. And actually, I should announce a contest. Basically, what I'd like to do, I brought a copy of my book, and I will have a presentation about API design tomorrow. So I'd like to give this book to a person who creates application that runs in a browser and runs with Java instead of JavaScript, using the tool that I will demonstrate in a few minutes. Okay, so right now I'm in middle of the slides, so it's time for demo. And actually, please, if you have questions, shout and ask, because basically there is a lot of things to demonstrate and to show, and I don't know what would interest you. So if you have question, if you want to see something, ask. Okay, so the first thing is how to create a project that can run in a browser. So this is NetBeans IDE version 7.4, which has been released this week, or maybe will have been released next week, but this is a release candidate that's definitely out. So the support for this project that I'm going to talk about is not part of the standard build. So what you need to do is to go to plugin manager and download something which is called Actually, let me do it here. HTML, Java, project support. And if you have this module, you can then start to create applications for the browser without JavaScript, with Java application logic. So, okay, let me do it. JDD demo, okay, package name, test JDD, and that's it. Okay, so basically this created a project, and well, let me show you what it does. So I can basically select it, do run. It will build the project using Maven. So basically, all the NetBeans ID is there only to help you get started and provide some tooling. But otherwise, all the functionality is available as Maven plugins and Maven archetypes. So basically, you can use it from command line, and it actually works in other IDs as well. So this is a HTML page, and well, yeah, I can change something, JDD. I can press the start button, do some simple animation, stop it. And actually, this is something you could do with JavaScript, but in this case, there is no JavaScript at all. So now, about web pages, how this is done. Okay, so this is the web page. I will collapse the style, and then here you can see the HTML. It uses a data bind attribute. Does anyone know what it means? What the data bind attribute means? Anyone heard of Knockout.js? One? Okay, so I'll talk more about that. So Knockout.js is one of the 3 most popular JavaScript frameworks. And what it basically does, it allows you to create a model in JavaScript, and then inside of your HTML page, reference properties and arrays in your model, and the Knockout.js will then take this input and take care of rendering the HTML and making the page dynamic. So, for example, here in the data bind attribute, we say, okay, this is input element, and I'd like to reference a property message inside of my model. And use it as a value for the input line. And actually, NetBeans 7.4, it started with NetBeans 7.3. We basically concentrated on support for HTML5 and JavaScript. And in NetBeans 7.4, we improved that, and we also have support for Knockout. So if you want to use Knockout, you don't need to remember all the syntax, all the bindings, all the Knockout bindings. You can basically just press Control Space and get code completion and see all the supported bindings that are available from Knockout. And basically what I do, I just piggyback on this support, and I'm using it in my project with Java. Okay, the next thing to show, here is a button. The button may be enabled or disabled, and the state depends on the value of property on. That will be Boolean property. And next binding to show is for each. So basically, you can also access arrays in your model. So this basically says, okay, there is an array, there is a property words with which is array of, in this case, strings. So please go through the array and iterate it. Okay, so this is the HTML page, and now let's look at the model. Okay, data model. So basically, this is it. Those 31 lines are defining the model and then driving the whole behavior of the HTML page. So basically, one goal that I wanted to achieve was to make Java even more efficient and more smaller, the code written in this library, more smaller than the similar code written in JavaScript. And actually, you know how it works with Java. Everything is done with getters and setters. And to type a setter and getter, it's so much code. And I wanted to eliminate that. So basically, I'm doing that by using annotation processors. I defined an annotation called model, and it basically and associated it with annotation processor. And probably, does anyone know what annotation processor is? 1. Okay. 2. Annotation processor is a way how you can hook into Java-C compiler. Basically, whenever Java-C compiles a code, if it finds out that there is an annotation processor registered for some of annotations which are in the code, it will invoke you. It will call you, and you can do some processing. And what I'm doing in this case is I'm basically generating a class named data. And into this class, I'm about to generate property message of type string or property on of type boolean. That's the second line. And also, in addition to that, there will be a derived property, words, which is based on the value of the message property and basically splits the message into 6 words. So we have a model, have something to rotate in the demo. And then there are also callbacks. So if you saw the application, if you remember how it behaved, when I clicked a button, I started the animation, and then I could also stop it. And this is done by defining a function, which will later be called if the user presses the button in the page. Okay, so what I am going to do now, I will show you debugging. So let's do debugging. Debugging. JDD demo debug. Okay, the application started, and if I press start button, actually the IDE stops here, and basically I can do, it's real Java. It's you can see the stack trace, and actually, if I'm able to click there, no, I'm not. Actually, the stack trace itself really shows that we are being called from a browser. In this case, the browser is basically JavaFX web view, which renders the HTML and runs inside of the Java virtual machine. So this is really real Java as you know it. Okay, I can continue. It rotates, and I can also put a breakpoint to the words, to the method that defines the words property. And if I change something, like J, immediately everything stops, because I basically changed the value of the message property. And we know that the words property is derived from the message, so the framework called me back. I can do the computation, and you can see there is J instead of Java. Okay, so that's it. So basically what we have is a technology which can show HTML page, allows you to define your model for the page in Java, and then display it in a JavaFX web view. This is basically an application which can be zipped and distributed to end users of your application, which are using desktop computers. But you may ask, where is the back-to-browser thing? Because I promised to run the same application in any browser. And actually, well, the only thing you need to do to run in any browser is to change the profile. You know, Maven projects come with profiles, and you can slightly modify what they do, or what the build does by selecting different profile. So actually, let me expand the runtime dependencies. So that's actually what will change when I switch the back-to-browser profile. The code remains the same. The libraries we compile against remain the same. Just the supplementary libraries, the runtime dependencies, are going to change. So let's do it now. And you can see that instead of FX implementation of knockout, the KO stands for knockout, I switched to something called back-to-browser implementation of knockout. And now I can run it. So the application should start. It needs to recompile and start. And now it takes about 5 seconds, well, usually, where we are basically booting up the Java virtual machine, the back-to-browser Java virtual machine. But that's the virtual machine that I was working on for last year. And basically, the behavior of the application is the same. It can change to JDD. It can rotate, it can do all the stuff. Just it runs inside of the Chrome browser, and there is no hotspot. This browser does not have support for Java in the traditional form. The support is injected into it by the back-to-browser virtual machine. Okay, so that's basically the demo. And that's end of my presentation, unless you have some questions. Questions, please? One there.
Just 1 second.
You can ask in Polish if you want. I will at least practice my translation skills.
Okay, so my question is, does it mean that you rewrite the whole JVM in JavaScript?
Okay, good question. So now let's look at the source code of back-to-browser virtual machine. So, okay. So basically what I'm doing is I wrote a code which can take bytecode, the format of the class file, and convert it into executable JavaScript. And the code is basically here in these 10, 15 classes. And the main important, or the most important part is bytecode to JavaScript class, which basically, this is the main method, compile. It takes input stream, which represents a single class file, and emits the JavaScript code, which does the same thing as the original, as the bytecode would do inside of a real Java virtual machine. And now how it's written. So basically this is some, so for each class I basically generate a function, one function named just like the class. And inside of it I have some initialization stuff and methods. And now what I'm trying to do is to find out, generate a method. Generate method here. Okay, so this is probably the most important part. Basically, I get the bytecode of the method, and then here is a huge switch over all the over all 200 instructions of the Java virtual machine, and for each of these instructions we emit some JavaScript and generate some code. So you can see that basically it's many of the instructions behave the same. They just take some value and move the and put the value somewhere else. Actually, when I started, I followed the Java virtual machine definition, and you may know that Java is stack-based virtual machine. So basically, when you want to invoke an operation, you need to push something on the stack, push operands on the stack, push another operand on the stack, invoke instruction, the operands will disappear from the stack, and the result will appear on the stack. So this is how Java is, the bytecode is designed, and I was using that approach as well. But it turned out that I cannot optimize, or the code is not fast. It's basically slow because the browser cannot optimize for the values of the variables. In modern browsers like V8 engine from Chrome are capable to detect whether a variable is of type string, object, or number, or array. And based on that, they can optimize the code. But when I was using the stack-based architecture, this was impossible because the stack contained mixture of values of integers, of doubles, and arrays, and anything. So basically, the code could not be optimized by the browser. But since then, my colleague in Prague helped me and rewrote that to register-based architecture. So right now, basically, we are working with registers, and we are making sure that we have one set of registers for numbers, one set of registers for integers, one set of registers for objects, and that's it, I think. So basically, since then, the speed increased about 4 or maybe 6 times. Okay, so I'm trying to find out some interesting instruction. Okay, for example, here, add 64. Well, in JavaScript, there is support for, there is just one type of number, a number. And there is no difference between integers, longs, doubles, everything is a number. And actually, it's relatively comfortable up until you try to emulate long numbers, Java long numbers in JavaScript. Because in fact, long has length of 64 bits, and double itself uses only 53 bits, and the rest is mantissa, an exponent. And we find it out that we are losing precision. So what we had to do was to write emulation library that supports longs and emulates longs inside of JavaScript. And most of those operations were easy to implement, like shifts and plus, minus. But you wouldn't believe how complicated it is to divide two longs if you can only divide 32 bits integers. That's a really long function. Luckily, it was not written by me. Okay, so that's basically it. So based on bytecode, I'm generating JavaScript. And actually, the first milestone that I wanted to achieve was basically run this virtual machine inside of itself. So I wanted to create really small Java implementation of Java, which is and a virtual machine, which is capable to run from its inside of itself. Because then I could be assured that I can basically do the compilation, the compilation from the bytecode to JavaScript inside of a browser. And so right now, basically, I have two modes. I can do ahead-of-time compilation and just-in-time compilation. You can compile on your development computer, or you can really deliver jar files to the browser, and the browser will do the compilation for you. One thing that the previous presentation in this room was talking a lot about test-driven design. So tests are important. Tests are very important. Otherwise, the whole thing would not be stable at all. So let me show you one of the first tests that I created. So basically, here is a class which contains some static methods. And I think this one was the first one that I started with. I basically wanted the virtual machine to be able to add one number to another. Okay, and then here is the test. Power -1 at rand reminder, wow, XOR, and increment plus 3 plus 4. 3 plus 4, okay, here is it. So this is basically the test, and it says, okay, please, dear virtual machine, load the static method class, convert it into JavaScript, and then the result, invoke method sum that takes 2 integers and returns 1 integer. That's the I stuff. And the result should be 7, and the parameters are 3 and 4. So of course, if I run it, the test will pass. But let's change it. And okay, running, debug, no, run focus test. I don't want to debug that. Definitely not on stage. So right now, what we should see is that the test fails because 4 plus 4 is not 7. And when it fails, it actually emits the JavaScript that was used for the execution. So get ready for some huge JavaScript experience. I will collapse that and collapse view, editor, code faults, collapse all. And okay, here is it. And now I should try to expand it. Well, you know that it's Java virtual machine. What you would expect? It just needs to be. It's long. Okay, so now hopefully I'm expanding the right thing. Expand. No, I need to use mouse, which is dangerous. No, okay, it's blocked. You know, NetBeans editor has some problems editing this 2 megabyte files. But anyway, so basically this is the structure of the virtual machine. There is a VM object, and inside of the VM object you have basically definition of all classes which are used in the virtual machine. And each class is represented as a single function. So tell me what class you want me to expand, and so you can see the code. Null pointer exception, that should be good. Null pointer not this way. vm.java lang null. No, still wrong. Null pointer exception equals. Okay, here is it. So let's expand that. So basically, the virtual machine calls this method whenever it needs to get access to the null pointer exception class or its instance. But the first time it calls it, there is some initialization steps. So the initialization step basically says, okay, there is some static field, and wow, maybe that's wrong. Okay. No, it's not. It's okay. So there are some fields, static fields, and then there should be some methods. For example, constructor. Here is it. This is constructor. And let me expand everything. Okay. So basically, this is the bytecode converted into JavaScript. So what it says is, okay, take first argument and then pass it to super constructor, and that's it. Okay, so I probably take another question.
So this JavaScript file is now 2 megabytes big, right?
Right.
So have you tried to use this with the Google compiler to crunch it down?
Yes. So basically, this is just the JavaScript file which is readable. Of course, I also have the unreadable version. Well, that's what the Google compiler does. It just minifies everything. So I can probably show it. Virtual machine, target directory. This one should be minified, and it's 1 megabyte before compression. Basically, if you compress it, then the download size is 200 kilobytes. So it's not that bad, but then still there is those 5 seconds that are needed for the initialization on the computer before Chrome parses everything. Yeah. So okay, this we are using Clojure, the Clojure compiler from Google.
Okay. And could you show how this thing with the jar file loading in the browser works? Oh, sorry.
Okay. So, well, that was a painful month, I have to admit, because the implementation of zip inside of hotspot. Okay, so I'll start from a different angle. So basically, you have seen the virtual machine, but also Java is not just the virtual machine; it's also libraries. So actually, what I did is API profile, but minimal profile. What I did is I basically took classes from OpenJDK project. Let's try object. Okay, object. So I expand the copyright notice. So this is really a class coming from OpenJDK. And when I got these classes, I also needed to somehow re-implement their native methods. So for native methods, I'm using the JavaScript body annotation. Okay, for example here. So it basically says, okay, this is a register to string method, but instead of doing some bytecode transformation and running it in Java, rather than that, please execute this JavaScript. Let's see if there is something else. For example, hash code. So default hash code is basically computed like this. So, I'm sorry. What was your question?
I wanted to see
the zip file. Okay, so what I'm doing is basically getting all the libraries from OpenJDK. This is JDK 7, actually, sources for JDK 7. But the problem with that is that there are no Java sources for unzipping files in Java because all that is native code. So actually, I had to write one myself. I tried to write one by myself, but it was not easy. But yeah, I found a library which is, I think, JZip or something like that, and that's what I'm using here. So I have implementation of the unzipping stuff, and then the loading. The loading is going to be in the virtual machine. Zips. Okay. So basically, this is the implementation that that downloads the jar file, scans through it to find out what are the entities in the jar file, and then can serve individual entities. So yeah, I don't want to look at that.
Well, could you show it in the browser with Firebug or something?
Okay. Yeah. Okay. That's I need to do this. Maybe switch to the browser. Okay. So actually, this is the development mode. So rather than really unzipping the jar file, when you run it from the IDE, it tries to serve individual classes directly from the disk. So it's not using the jar file, but for you, let's do it. Actually, where I put the project, TMP, JDD demo. Okay. target. Oh no. Maven install bck2brwsr. So as I said, everything can be done from command line. It's not NetBeans connected. Okay, so now we should get a zip file. So the zip file is in target directory, unzip, JDD, bck2brwsr zip file. Okay, and I need to start it, which will be also funny. Bin. Because Chrome by default does not allow you to load links from one file another file, so I need parameters so it's available. So this works. Index. Okay. So now network. I need to kill the Chrome first. Otherwise, it remembers the previous settings. So Chrome. Okay. Change the font, bigger. I will try to. Okay, so now it's doing something. And yeah, okay. So let's put console on, and yeah. So basically, do you believe with if I show these messages, or should I try also network?
Network, please.
Network. Oh. Tomáš, who does not believe. Okay. So yeah, it downloads the jar files. Convinced now?
Amazing.
Okay, thank you. Another question? Oh, in the back. The last guy sitting.
Well, I've got two questions. The first one is based on this JavaScript VM. What limitations does it have versus the traditional VM? And secondly, if the answer to that's none, could we run Tomcat within this VM?
Okay, so so guys, I will talk, and meanwhile I run a demo. Okay, it's called Dew. Some people call it Tulach module with Java. So let's run it. Okay. So limitations. Yes, the virtual machine has limitations because I didn't want to build a fully featured Java virtual machine. Actually, before I started this project, I did a research over internet trying to find out who is doing the same thing. And actually, there were about 4 projects trying to implement Java virtual machine that I found. As far as I can tell, all of them are dead now, except one. It's called Doppio. So there is another machine written in TypeScript or something like that. But their goal is to run any Java program unchanged. So really, if you want to run anything, you can, probably with Doppio. The goal of bck2brwsr is really create this small subset of Java, so we can use Java tools, Java IDs, bytecode manipulation, and stuff like that, and still run in the browser. But I wanted it to be as small as possible. So one thing which I do is, if it's possible and sort of reasonable to throw security exception, I throw security exception. So you cannot basically have your own class loaders. You cannot access files. Oh, there are none anyway. But basically for these things, I'm deliberately throwing exception, security exception. And so far, I have not seen much limitations. But it, of course, requires that you start to write libraries from scratch or create new libraries. But that's okay, because JDK 8 is coming with profiles, and all of us will have to adjust our libraries to be able to run on Compact 1 or Compact 2 profiles, some smaller subset of Java. Actually, I submitted few patches to Grizzly HTTP server because they were not able to run on Compact Profile 2, and I wanted that to get bck2brwsr to phones. So basically, all the libraries will need to be adjusted anyway. So probably the biggest limitation that bck2brwsr virtual machine has, you cannot start new thread. It does not support threads. It's single-threaded. And you can, of course, start workers in the JavaScript sense, but they are completely isolated, so that's not the same as Java threads. But anyway, because we don't have threads, you probably cannot run Tomcat, so sorry. But one thing that you can run is JavaC. So here is an example. This is basically JavaC running inside of the browser and really doing the compilation in a browser. So you can see, and actually it's not that slow. If I stop typing, then for a half second there is a delay. The system waits to recognize that I stopped typing, and then it does the compilation. So yeah, this can be fixed like if true, then the error is gone. Error is gone. Error is not gone. Actually, error is gone, but it was not visualized properly. Okay, and if I do public void x, yeah, you can see that that the JavaC just kicks in and shows the errors as well. Yeah, so I think the virtual machine is powerful enough to run real applications, but not Tomcat yet. Okay, I have 3 last minutes. So let's do one demo that I forgot to do. And this is basically a promotion of NetBeans. I mentioned that we have really good support for development of HTML5 applications. And I'm really reusing it. So let me run this application and hope that it will start. So actually, what I can do, I need to make it smaller. Okay, so here you can see the actual structure of the page. So if you want to develop HTML, NetBeans is the best tool out there. So not only basically we support selection mode. So if I choose selection mode, I can select here, and it will show me where the hierarchy is. If I go here, I can go to source and really see really modify the source immediately, which is better than browsers do, because in browser you can modify the source, but then you need to apply it to your source code. And one last thing to show, that's the style sheet. So basically here is also CSS styles associated with the selected element, and you can play with them, modify them, and the changes are directly projected to the source code. So that was the promo part. In a minute. And I'd like to officially announce the contest. So by tomorrow, 3 p.m., whoever uses this technology and publishes some application on a website will get this book if you stop by on 20 API Paradoxes talk. So thanks, and of course you can talk to me later. No questions, no, sorry.
Yeah, we're running out of time.
Okay, so that's all. Thank you for your attention.